In this lesson, our objectives are to be able to identify and use similar triangles, also to be able to use similarity theorems to prove triangles are similar. Similarity theorems. Recall that similar triangles have congruent angles and proportional sides. However, we don't have to know all of this information to know that our triangles are similar. There are some shortcuts. In fact, there are 3 postulates or theorems that help us with these shortcuts. The AA similarity postulate, also known as angle-angle. This postulate tells us that if 2 angles of a triangle are congruent to 2 angles of another triangle, then the triangles are similar. For example, in these 2 triangles, if angle A is congruent to angle D and angle B is congruent to angle E, that is enough information. First of all, remember we know that when 2 angles are congruent to 2 angles, by the third angles theorem, the third angles must also be congruent. And as you saw last time, whenever we make congruent angles, the sides are going to be proportional and vice versa. So this is enough information to say that triangle ABC is similar to triangle DEF. Let's look at another one. The SSS Similarity Theorem, or side, side, side. This theorem tells us that if the corresponding sides of 2 triangles are proportional, then the triangles are similar. For example, let's say in this triangle, the 3 sides are 2, 3, and 4 units long. And in this triangle, the sides are 4, 6, and 8 units long. How do we see if the corresponding sides are proportional? Well, we make ratios because remember, proportional has to do with ratios. So let's match up corresponding sides. How do we know which ones are corresponding? Well, of the 3 of these, this one's the smallest, and of the 3 of these, this one's the smallest. So if we put 2 over 4 and reduce it, we get 1/2. Let's check the other sides. This is the medium side on the first triangle, and this is the medium side on the second triangle. So we make a ratio. 3 over 6 simplifies to 1/2 as well. So far so good because we're getting the same ratio. Then the biggest side, the 4 and the 8. Now, I'm underlining these numbers. I'm not making congruent slashes. So let's actually make sure that I'm not touching the sides because I don't want you to think I'm marking that the sides are congruent. I'm just noting which sides are corresponding. So largest over largest is 4 over 8, and that makes 1/2. Because all of these ratios are the same, the sides are proportional. And that's how we find the scale factor. The scale factor will be 1/2 because these sides are proportional to these sides, and the triangles are similar. Let's take a look at the last theorem. Side angle side similarity theorem. SAS for side angle side. This one is a combination of the previous 2. If 2 pairs, so just 2, of corresponding sides of 2 triangles are proportional and the included angles are congruent, because of course angles have to be congruent, then the triangles are similar. What would that look like? So we start with just 2 pairs of corresponding sides, such as this side being 2 units and this side being 3 units long, this side being 4 and this side being 6. The included angle means the one that is between. Included means between. The included angle is the one between. So if these are the two sides, they both touch at A. A would be the congruent angle to the one where these two sides touch. They touch at D. So angle A is congruent to angle D. Now we just check that the sides are proportional. So I've got the little side with the little side, 2 over 4. That reduces to 1/2. And the bigger side with the bigger side, 3 over 6, also reduces to 1/2. Because these ratios are the same, those sides are proportional, and those ratios give us the scale factor. The scale factor is 1/2. These triangles are similar by the Sss Similarity Theorem. So remember, you've got 3 shortcuts in order to tell that triangles are similar. Let's practice. Examples. Determine whether the two triangles are similar, and if so, state by which postulate or theorem, remember that's our angle-angle, side-side-side, or the combination side-angle-side. If they are similar, write a similarity statement. Find the scale factor where possible. Let's take a look at the first picture. So all I see so far is that one pair of angles are congruent. But remember, when lines intersect, we also have vertical angles. So also these angles are congruent. These are our vertical angles. So now notice in one triangle, and we can mark this like how we did in congruent triangles. We have an angle mark here and an angle mark here, and that matches in the other triangle. So angle-angle is one of our postulates. So it is true that these two triangles are similar. So we can write a similarity statement, and our postulate is angle-angle similarity. Usually you see that so that we don't confuse it with the congruence postulates or theorems. The similarity statement is when we match up the corresponding parts. So triangle GHJ is similar to triangle, so G has one slash, it goes with K. H is next, and H is the vertical angle, so H again in the second triangle, and the letter that's left is I. There's our similarity statement to show the triangles are similar. Next, first of all, notice that we do have two triangles here. There's this little triangle, CDG, and then there's the larger triangle, CEF. Notice that they overlap each other and they share this common angle right here. So that angle is congruent to itself. Remember that that's called the reflexive property. These are reflexive angles. And by the reflexive property, since it's the exact same angle, it's congruent to itself. Now, it may be helpful that we draw these two triangles separately. So I'm going to draw the little triangle and make sure it looks little, CDG. And I'm going to label the two sides they gave me, 15 and 20. Then I'm going to draw the larger triangle, CEF. CEF. Now I also have to label the two sides they gave me, but I've got to do some adding first, because from C to E, it's 15 and 12 put together. That's 27. And from C to F, that's 20 and 16 put together, which makes 36. Let's not forget the congruent angle C that we marked from the reflexive property. Now, which shortcut, postulate, or theorem does this look like? Did you say side, angle, side? Then you'd be correct. We can mark with a S, an A, and an S if that's helpful. But we can't just jump to that conclusion. We've got to see, are these sides proportional to these sides? So let's take the small number from the first triangle and the small number from the second triangle, and let's check it out. So 15 over 27, that simplifies to 5 over 9, and the large side, 20 over the large side, or I should say the longer side over the longer side, 36, also makes 5 over 9. So sure thing, since they equal the same thing, those sides are proportional. So we determined that we were using side angle side. Usually that comes last because in a proof that would be the last thing you write if we're proving the triangles are similar. Remember how we get the scale factor? That's right, from those ratios that are equal, 5/9. How about the similarity statement? Well, let's try to match up the corresponding parts. In the first one, I'll go from C to D to G. Because angle C is congruent to angle C, C goes first. D came next. Notice I went over the short side first. So from C, I go over the short side. 27 is shorter than 36, so C to E, and then the last letter F. So we have similar triangles, and there's our statement to say so. In this one, I notice I have two angle measures, and these are different from these two angle measures. I do have this angle congruent to this angle, but that's only one angle. And if I'm going to use angle-angle, I need two pairs of congruent angles. But since this one doesn't say anything, it's probably best that I don't jump to conclusions and I try to find this missing angle measure first. Remember that all the angles in any triangle add up to 180. So 85 plus 45 adds up to 130, and then 180 minus 130 makes 50. So this missing angle measure is 50 degrees. Notice that in the other triangle, we have a 50-degree angle. So these angles are congruent, and I do have angle, angle, two pairs of congruent angles. So I'm using the angle-angle similarity. Oops, I just remembered back to SAS, I forgot the similarity symbol. What's the similarity statement? Let's match up the corresponding parts. So starting with the triangle at the top, I'll go from K to L to J. It doesn't really matter where I start. K was the double mark. The double mark in the bigger triangle is Z. L was the single mark. The single mark in the other triangle is X. And the letter I haven't used yet is Y. Example, select two relationships that would prove triangle JKL is similar to triangle PQR by the side angle side similarity theorem. So remember, the S is for the sides. We want the sides to be proportional. The A is for the angles. What do we want the angles to be? Congruent. So we need to pick one relationship from the angles and one relationship from the sides. Remember, pick two relationships. So because it's side angle side, one has to be from the sides, and this is the sides, and one has to be from the angles, and this is from the angles. Remember that side angle side says there is one pair of congruent angles. Those are the included angles. So what's the easiest way to look at this? Well, if we were to say that angle J is congruent to angle P, well, angle J is right here, and angle P is right here. I'm not making too many marks yet in this picture because I'm not sure that's the correct selection. If these were the congruent angles, that would mean that I'd have to be using the sides surrounding that angle, so JK and JL, which means J would have to be used in the proportion twice. I'm going to look in this proportion. I see a J, and I don't see another J anywhere but here. In this proportion, I see a J, and I don't see a J anywhere else but here. Same thing in this one. Here's a J, but there's no J anywhere else. So because I don't have the sides JK and JL noted, I know this is not the one I'm going to pick. How about the next pair? K congruent to Q. Okay, well, tentatively, let's mark angle K congruent to angle Q. So remember, that would mean I need side kj and side kl. I'd have to see the k appear twice in the proportion. Here the k does not appear twice. I only see it here. Here I do see the k appear twice. And in the last one, I also see the k appear twice. So let's keep looking. In the second triangle, because Q needs to be the included angle, I'd be using side QP and side QR. So in the ones where K was used twice, here I see Q is also used twice. But in this one, Q is only used once. So I know that this relationship does go with this relationship. Let's double check and make sure corresponding sides are proportional from here. So this says JK over PQ. Here's JK and here's PQ. That makes sense. KL over QR. So this side KL over this side QR, and that makes sense as well. So we do see side angle side with this relationship matched with this relationship. Example, determine which two of the three triangles are similar. Find the scale factor for the pair. So we're just going to have to try and see what happens. Let's start by comparing the first two triangles. Notice that all I'm given are sides. So I'm going to be using the Sss Similarity Theorem. Remember, that means the sides need to be proportional. So I'm going to start by comparing the smallest of the three sides to the smallest of the three sides. 16 divided by 12 simplifies to 4/3. Now I'm going to look at the medium side over the medium side from the other triangle. 20 divided by 16 simplifies to 5/4. Notice these two ratios are not equal. So it's not this pair of triangles that are similar. Okay, let's try another pair. How about the first triangle with the third triangle? Let's do our work with the ratios. Again, the smallest side with the smallest side. 16 over 20 makes 4/5. Then the medium side, 20 over 25. 20 over 25 makes 4/5 again. And then the largest of the two sides, 24 over 30. And that also makes 4/5. Since they all make 4/5, we have the correct pair. So we can say triangle ABC is similar to triangle. Let's make sure I match up the parts correctly. Large side to smallest side. ABC is largest side then smallest side. So this largest side then smallest side goes GHJ. And what's the scale factor? Of course, the ratio that they all came out to be. Thanks for watching.